Yeah, there's so many zombies. I go behind you, behind you.
Where? Ah!
I made this level, I don't even know where the heart is. Oh, shit, what the f? Oh, I'm at the heart, guys. I'm at the heart.
What is up, everyone? It's me, D2, and welcome back to my channel. In this video, I'm going to be sharing my workflow as a 3D artist, from asset creation all the way to final implementation. I'll also walk you through my thought process to help you understand how I make artistic decisions. For context, this game was made for an annual game jam at Blizzard, and we were given an entire month to work on it. However, since all of us work full-time, I only spent about 72 hours in total on this project. There are also 3 other programmers on the team: Alex, Mike, and Michael. We're mostly in charge of gameplay while I was responsible for the visuals. Also, just to clarify, this game jam was completely voluntary. It does not relate in any way directly to Blizzard and was simply a fun event hosted by the company's employees. We own 100% of what we created for this game jam and only used our personal hardware and software during the process. Now, with that out of the way, let's jump straight into the making of the most unbalanced multiplayer zombie shooter game in the history of game jam. So Mike and I were actually on the same team from last year's Blizzard Game Jam. We worked together on a game called Faint Sight, a single-player dungeon puzzle game that centered around using an echolocation mechanic to navigate the level. We had a lot of fun working together, so decided to team up again this year with the help of some friends. If you're interested in checking out Faint Sight, I have a link in the description. Go play it and let me know what you think. For this year's pre-production, we spent at least 6 hours just brainstorming what type of game we wanted to make. We first started with everyone hopping on Miro, or Miro, however that's pronounced.
Miro.
We first started with everyone hopping on Miro? Dang it! And just threw out things that reminded us of the word growth, which was the theme of the jam. Once we had a decent list to work with, we then grouped everything that was similar and started boiling down what kind of game we would be making if we were to pursue each idea. And ultimately, somehow, we ended up with the idea of making an asymmetrical 1v4 multiplayer zombie shooter game that takes place in a fantasy universe where zombies are the good guys trying to defend themselves from human invasions. Yeah, it's a mouthful. Basically, one player playing from a top-down perspective, like in League of Legends, will go against up to 4 players who play from an over-the-shoulder perspective, like in Fortnite. Friendly advice: don't attempt to make a multiplayer game for a game jam. We thought it was a good idea because we had a month to work on it, but in reality, we only had a few hours each weekend because everyone was busy. The majority of this game was actually made in the last 2 days before we submitted it, where all of us stayed up long hours just to scrap everything together. Also, in case you're wondering how the idea ties to the theme growth, me too, but we went with it anyway. We decided on a reverse tower defense style gameplay in which the single player playing as the defending player can deploy zombies and barricades to protect its zombie heart from being destroyed by the human soldiers who are trying to take it down. In the beginning, we wanted to make this game in a colorful cartoony style similar to Plant vs. Zombies. And as you can see, that turned out exactly how we envisioned it. Well, that's the fun part about game jams. You never know what to expect. Going into production, I knew right off the bat that I needed to tackle the character model first. Being an environment artist, I knew that making a half-decent character model will likely take me the most time. Usually, depending on the asset I'm creating, I'd either start by modeling a low poly or low resolution, blockout, and a modeling program such as Blender and Maya. Or if I'm creating something with a more organic form such as a character model, I would instead start with sculpting using Blender or ZBrush. The first thing I did when working on the character was to import another character model as reference for size and proportion. A standard game character model is usually around 2 meters high, so I wanted to make sure I matched that. This character was supposed to be cartoony with stylized proportion, like a chibi. Speaking of chibis, I made a video sharing some tips on how I went from making games like this to this. Go check it out if you haven't seen it yet. Anyways, back to making the game. I gathered some references and began blocking things out with simple primitives. At this stage, I'm not really too worried about making things look good. I'm only focusing on making sure the proportion feels right. One of the main things to keep in mind when starting a sculpture is to always start off with as low resolution as you can. Similar to the reason why I like to make assets by modeling a low poly blockout first before I start sculpting, you want to make sure to have the big shapes defined clearly before you consider adding any details in. Working with a low res mesh is much easier to get clean results and is way more forgiving if you make a mistake. It also helps you focus more on the most important aspect of your model, the silhouette. A good silhouette can help the viewers identify your art much easier, which often helps make your art feel more natural and pleasant to look at. Once I was happy with the silhouette and proportions of the model, I started refining the character's features and adding in secondary details like patterns and folds. These secondary details shouldn't affect the overall silhouette too much, but should help create more visual interest by breaking up the internal shapes. After that's done, I used some elf brushes to quickly layer surface details like cracks and holes, and a bit of subtle noise as well. These details will help a lot later when it comes to texturing. Here, I'm using some of my own custom-made alpha brushes and also some from a free brush package made by Orb, which, in my opinion, is one of the best free ZBrush packages out there. Link in the description if you're interested. Within about 10 hours, I had a decent model to work with. It was a super simple design because I had a limited amount of time, but it was good enough for the game jam and I wanted to move on. The next step after sculpting is every 3D artist's nightmare:
the retopology.
Retopology is basically the process of making a high poly mesh or high polygon density mesh and creating a low poly version of the mesh that is more optimized for games and animation. Topology is a big topic, especially when it comes to the creation of models that have soft skinned animations such as characters and creatures, where when animated the model deforms in a soft and organic way. I'm not going to discuss it too much here, but the main thing to take away from this is that a good topology can help maintain the shapes of your model a lot better when it's being animated. It also helps generate better results when baking PBR texture maps such as normal, AO, and curvature map. I'll talk more about these maps in the texturing section of this video. Once I went through the painful process of manually retopologizing my model, I was ready to start using unwrapping. I like to think about this process as skinning an animal. You take a 3D mesh, define where you want to cut the mesh open, then spread it flat onto a 2D surface. Like you're turning a deer into carpet. Oh dear. You then pack these UV islands on a single or multiple UV maps that allow a 3D program to read the textures and display them on your 3D mesh. Once my UVs were properly packed, it was time for the fun part: baking and texturing. There are many ways to bake and texture your model, but the most standardized way to texture a PBR asset in the industry is to use Substance Painter, which is what I'm using here. Baking refers to the process of transferring details from your high poly model onto textures that contain certain useful information used by a rendering engine. Some examples of baked maps include normal, ambient occlusion, and curvature map. Normal map helps the engine calculate how light bounces off the surface of your model. Ambient occlusion, or AO map, helps the engine apply contact shadows without needing to calculate it in real time. Curvature map, on the other hand, contains information about the peaks and valleys of your model. Here, you'll see me utilizing a curvature map to help add brighter highlights to the edges and darker shadows to where the concaves are. There are many more tools and techniques for texturing your PBR assets. Let me know in the comments if I should make another video to dive deeper into that. Once I'm happy with my texture in Substance Painter, I then brought my model into Unity, set up some basic lighting, and inspected my texture directly in the game engine. This is one of the most important steps that often gets overlooked. It is important to remember that every software has a different rendering algorithm. No matter how great your texture looks in your texturing program, if it doesn't look good in the game engine, it doesn't work. One of the things you might notice on screen is that the model looks a lot shinier in Unity than it is in Substance Painter. This was a roughness map issue, and to fix that, I had to keep going back and forth adjusting my roughness values in Substance Painter until it starts behaving in Unity. For animation, since this was a game jam, I decided to just use Mixamo. Mixamo is a free Adobe tool that has a bunch of motion capture character animations that can be downloaded for free. You can upload your own character model and preview how each animation will look in real time. This tool is super useful and is completely free and often suffices for small scale projects. There's a link in the description if you want to try it out. So I downloaded a bunch of basic character animations like idle, running, strafing, and shooting, and combined everything into one file and imported that into Unity. At this point, all that's left is to set up each individual animation clip, then put it all together in an animation controller. I worked with Alex here to create the attributes in the animation controller so his player script can trigger and blend my animation properly based on player input. Since we wanted the human characters to be able to attack, I moved on to quickly model a hunting rifle. We thought giving the human players a longer cooldown per shot would help balance the game so we can be more precise on how much HP we can give to the zombies. However, we later realized that this became one of the main reasons our game was so unbalanced.
Yo, the mecha is way too OP, dude. You just like lock me up and I just get cornered and die.
Once the rifle was in, Alex started working on adding look IKs so the character model will always aim its body towards where the player is looking at. This is a pretty simple process to set up and we were able to get it working very quickly.
His feet are like kind of twitching. That's so funny.
We have prone.
It's a feature.
He's just hanging out. Well, the aiming seems to work now though.
Ship it.
Well, I guess it didn't turn out quite right at first, but Alex was able to figure it out eventually.
Oh yeah, that looks good. That's great.
At this point, we had some basic building mechanics that Michael had put together, server versus client connection setup that Mike had done, and a simple character controller that Alex had made.
What the f?
So we threw the character in a temporary map created by using pre-existing packages to test things out. Here we had a discussion regarding whether or not we should have terrain elevations in the map as it creates potential navigation problems. We ultimately decided on making a map that is mostly flat so navigation with dynamic placements of obstacles would be easier to design and implement. I repurposed a human character model and modified its texture to give it a zombie look. It was a quick process because I mostly just had to change the colors, then throw in some dirt and grape juice on it, and boom, a zombie was born. I then sculpted a very abstract looking corrupted zombie heart, scrapped it because I forgot we were working on a cartoony game, and sculpted a literal heart that is wrapped around by evil tree roots, because it just made sense. For maximum gross effect, I animated the heart by hand with a few simple idle animations, an on-hit animation for when it gets attacked, and a spawning animation for when it automatically spawns zombies because that's part of the game. Up next, I modeled some simple wired barricades and gave them a falling animation along with a preview shader and dropping indicator effect. This way, the zombie player can preview where to drop the barricades, and the human players can have time to react to the barricades falling out of the sky. With everything set up, Alex and I jumped into a small test map as human players, while Mike played as the defending zombie player. This was the first time where we celebrated the game finally reaching a playable state. There are still a lot of bugs, like how the preview mesh on the barricade can be seen by the attacking humans, and how dropping barricades on the player will result in them being pushed away abruptly because of Unity collision. But to our surprise, we actually had a lot of fun just running around avoiding barricades while trying to take down the zombie heart. Hey there! If you made it this far in the video, consider liking and subscribing. It'll really help me understand whether or not I'm making the right type of content for you all. Anyways, back to the video. At this point, we had about 3 days left before the game jam was due, and I finally had time to create environment assets. I first started by modeling out a bunch of leaves for the pine trees I was going to create. I like to model my foliage because it gives better results when baking normals, which will help give the leaves an illusion of having thickness. Once the leaves were assembled, I threw on some simple colors and started creating the trees. I simply modeled a cylindrical trunk, then duplicated, scaled, and rotated the 2D leaf cards to create an illusion of volume. Once they're assembled, I then threw them into the engine and began working on the shader. These trees are using a shader I made that dynamically displaces the tree's vertices based on the wind volume input in the material setup. This type of shader is called Vertex Animated Shader, and is a much cheaper and easier solution if you want to fake movements in your asset without actually rigging and animating it. It does have its limitations, but for simple swaying movements in trees, grass, and water, this is the most efficient way to do it. There are already some tutorials out there that explains how this works, but let me know in the comments if this is something you want to know more about. I then added a random colorization function to the leaf shader so whenever the same tree is placed in the world, the tint of its leaves will be slightly different from one another, creating a more natural feeling. I also added a subtle color gradient that makes the leaves closer to the bottom darker, so the trees feel more interesting to look at. These are all very subtle additions, but can often make a big impact on visual fidelity. For the tree bark, I basically grabbed the tiling texture that I had previously made with Substance Designer by following this tutorial, and altered it slightly so the shapes are more boxy and fits our stylized look better. I then did similar tweakings with the mud, rock, and grass texture that I also previously made by following tutorials, and quickly threw them in game. For the grass, I modeled some simple boxy grass shapes, then baked and textured them exactly how I did with the tree leaves. The shader used on the grass clumps is a super basic version of a vertex animated shader that has an extra function to fade out the bottom of the mesh so it blends in better with the texture on the terrain. For the modular rocks, I reused the same triplanar shader and models I made for my Demeter project because we were running really short on time. What a triplanar shader does is basically, instead of rendering the texture through UV space, tiling textures are projected on the model from the X, Y, and Z world axis in the game engine. This is a more efficient way of making bigger and modular environment assets because you can reuse the same texture on multiple models. This also helps fight against textile density issues because the bigger the asset is, usually the higher resolution your texture needs to be to accommodate for it. But since the triplanar shader projects tiling texture in world space, you can easily tile the texture to increase the rendered resolution. There are more benefits of using triplanar shaders, like projecting moss or snow texture on top of your asset. It is very widely used in AAA games and can help create high fidelity assets really efficiently. Once the assets were made, all that's left was putting everything together in the engine. I sculpted terraces on the terrain to differentiate playable and non-playable space, painted rock textures on the cliffs, and slapped a bunch of modular rocks on, and mixed in grass and mud textures on the flat surfaces. I then painted the grass clumps with Unity's Terrain Detail Painter. For the trees, however, instead of painting them like I did with the grass, I decided to place them by hand. I did that because I wanted more artistic control of how the trees are arranged since they take up the majority of a player's screen. Most of these trees are placed on platforms players don't have access to, so this way they can't abuse nav mesh around the trees to cheat our super basic enemy AIs. And after a few hours of blood, sweat, and hard work, this was the result. While that was depressing, I mean, fun! But yeah, we ended up switching gears last minute to make it more moody, because where would the fun be if everything goes according to plan? At this point, we had a few hours left before the game jam was due and the show and tell begin. We started playtesting in groups to see if we can find any bugs, and man did we find a lot. Human players were able to climb up the rocks and break the zombie AI, so we came up with a solution by scaling up the rock colliders.
You can still go up. There's something with the controller, man. I don't know if changing the collider can change.
That didn't work so well, so we came up with another solution by scaling up the colliders more.
I have a bad feeling about this.
And my computer crashed. Eventually, we gave up trying to hack it and just fixed our player controller code instead. Kind of. There were a bunch of other bugs like animation breaking when players die, or being able to deal damage to the barricades before they appear to be dropped on the floor. But the biggest problem of all was that we had no time to tune and balance the game. The zombie player automatically spawns up to 20 zombies that will seek to destroy the human players. On top of that, barricades and additional zombies can be manually spawned at a rather low cost to the zombie player. Each barricade takes 10 shots to break, while the zombie player can deploy dozens of them in a span of seconds. We tested multiple times with a 1v3 setup, and humans always get wiped out within 5 minutes. Regardless, all 4 of us had a blast working on this game and were happy with what we were able to scramble together in a given time frame. If you're interested in trying it out, the link to the itch.io page is in the description. If you do, let me know in the comments the funniest bug you find. You do need at least one player on each team to be able to play though, which is another thing we didn't consider when we began making this game: accessibility. If there's anything I learned from this, it is to never attempt to make a multiplayer game during a game jam. You can free up so much more time to prototype and try out different designs. It will be way easier to playtest during development, and it's so much easier for everyone else to just jump in and try your game out. But I thoroughly enjoyed working on this game and learned a lot more about how to efficiently work with other disciplines. Well, that's how we made the most unbalanced multiplayer zombie shooter game in 72 hours. Hopefully this gives you some insight on my workflow as a professional game artist as well. Don't forget to like and subscribe if you enjoyed the content, and be sure to check out some of my friends' work in the description. And with that said, I will see you all next time. Peace!